Now we'll go ahead and just jump right into the basics of CWDM technology and show you how this works. So what is CWDM? This is an acronym that stands for Coarse Wave Division Multiplexing. And don't let that long name scare you. This is very simple technology. So what this is doing is overlaying multiple wavelengths or colors on one single fiber link. So each wavelength is its own secure and independent data channel, and each channel is protocol and speed transparent, meaning that you can put in various speeds or various different networking protocols with CWDM. And then what this does is helps you increase the capacity of your fiber infrastructure by sending more channels over your existing fiber lines. This is very inexpensive when compared to the alternative solutions of laying new fiber or having to lease additional fiber lines or buying expensive switches. And also the implementation of this has little to zero impact on an existing network. So you can still run your legacy 1310 or 1550 nanometer wavelengths on this network and just overlay CWDM wavelengths right on top of them. So again, looking at CWDM, so data from virtually any type of communication protocol and data rates can be carried over the fiber, all the way up to 10 gig Ethernet speeds. Different protocols that can be sent over CWDM include Ethernet, the T1E1 or T3E3, as well as SONET, CPRI or CPRI, and serial protocols. So you can mix and match, send all of these multiple protocols over that same common fiber line. And so the primary benefit here is that the bandwidth capacity is significantly increased. So you can, again, send, instead of one channel over that fiber line, all the way up to 16 different channels over that same fiber. So in order to understand how CWDM technology works, let's take a quick look about how fiber optic data transport works. So in your typical fiber cable, dual strand fiber here, it's going to utilize one wavelength going in each direction here. So a 1310 send and receive going, each wavelength is going on that separate fiber strand. Now taking a look at a single fiber line, it's going to utilize that bidirectional technology where you have multiple wavelengths going in different directions. So a 1310 going one way and a 1550. So this was really the basis of how CWDM technology was invented. And now we're going to go ahead and take a look at how a CWDM network would work inside of a fiber cable. So light waves are going to be sent from an optical transmitter on each end of the fiber, and it's going to be bouncing off the walls of this fiber cable. So this is what a typical wavelength will look like. And wavelengths are measured from peak to peak here, and the measurement is in terms of nanometers. So with CWDM, you can actually add more wavelengths at a different wavelength, and they're not going to interfere with each other within inside this fiber cable. So here we've added a larger wavelength that's got a much smoother curve here, and it's not going to be interfering with the current wavelength in that fiber. Again, we can keep adding more wavelengths here at different wavelengths, all the way up to 16 different times to really pack in a ton of channels on this one fiber cable. Here's taking a look at all the different CWDM wavelengths as specified by the ITU. There's 18 different wavelengths, and they're between the 1271 nanometer up to 1611 nanometer, every 20 nanometer increments. And typically they're going to round it off from this 1271 down to a 1270 is the industry standard there. So CWDM is going to be using non-stabilized lasers and broadband filters to really filter out these different colors or wavelengths. Very cost-effective solution for enterprise, city networks, as well as service provider networks. And typically, the number of channels being used with CWDM is appropriate for these types of applications. I'll go ahead and take a look at CWDM multiplexers. So these are the hardware that's going to enable you to transport all that data over that single fiber cable. So these are for networks suffering from fiber exhaustion. And so again, you've maximized all your bandwidth on your existing fiber, so just completely ran out of bandwidth, either need to add more fiber or send more data over your existing fiber. So what you can do is you can multiplex or combine up to 16 separate channels on that same fiber cable. With CWDM multiplexers, these are completely passive, meaning that there's no power required at all. It just acts as a light filter for these different wavelengths. And as I mentioned, these are protocol transparent or agnostic, meaning you can put various protocols all on the same fiber cable at once. Now we'll go ahead and take a look at some of the various types of CWDM multiplexers. So a CWDM multiplexer is going to be used on each end of a common fiber line here, and we'll call them either a CWDM mux for short or a demux. So that will multiplex or demultiplex those wavelengths. So in this situation here, we have 4 different Ethernet switches, each with their own wavelength, being combined or multiplexed into this multiplexer module, sending all 4 of those wavelengths over a common fiber line to another CWDM multiplexer, which is going to demultiplex and send each wavelength to their own individual switch. Another type of multiplexer is called an optical add-drop mux, or an OADM. And what these are used for is to insert or remove or add or drop different wavelengths along a common fiber line. So in the application shown here, we've inserted an OADM, one-channel add-drop mux, into this network, and we're dropping off a 1570 wavelength at a separate location here to switch number D, and then adding some data from switch E back on that 1570 wavelength back onto the common fiber line. So these are great for, again, adding or dropping off wavelengths along a common fiber link. So as I mentioned, CWDM multiplexers are completely passive devices. So they do not require any power to operate, and they're going to pass all that data, all those channels transparently. They also support the data rates all the way up to 10 gig per channel, so you can do 16 individual channels of 10 gig each, or 160 gig. And with CWDM multiplexers, the nice part about it, there's no configuration needed at all. They're completely plug and play out of the box. You can also, though, insert a CWDM multiplexer into a powered chassis, and what this does is going to give you some management type capabilities. So you can easily monitor the wavelengths being used or the locations that these multiplexers are residing in. Now we'll go ahead and take a look at some different port definitions, or these are the names for all the types of ports on a CWDM multiplexer module. The first one is a channel port. And so this is going to be a port for each specific CWDM wavelength that's being inserted into the multiplexer. Another port is called the common port. And this is going to be where the fiber comes out of the multiplexer and has all those different wavelengths combined onto a common fiber line. There's also what's called a 1310 passband port. So this allows you to, again, overlay existing 1310 type wavelengths and have CWDM wavelengths going right on top of them, or you can use that as a service channel for management. And the last type of port is called the expansion port. And so these are used to cascade multiple CWDM multiplexers together and can also function as a 1550 nanometer passband as well. I'll go ahead and take a look at some different CWDM module types. First one is our 4-channel dual fiber mux. And so this is utilizing the upper one band, they call it, as far as the upper wavelengths within the spectrum here. So you can see each individual wavelength here has its own associated channel port, and then that common port to send all of that data out of that one port. You can also have it with that 1310 passband port, which is going to overlay all the data within this 1310 spectrum. Another type of multiplexer that Omnitron sells is the 8-channel dual fiber mux. So as you can see here, we're packing in a ton of different fiber connections into this compact device. So we have 8 separate wavelengths coming into this one multiplexer module and your common port. You can also get the 8-channel muxes with a 1310 passband port, but it's going to be a double wide here. So again, each one will have its own channel ports, the common port, and then a 1310 passband port for 8-channel muxes. Now we'll go ahead and take a look at some more applications here showing a 4-channel point-to-point mux using that 1310 passband port. So again, all the data is being sent from each switch with its own CWDM wavelength into the multiplexer and sent over to its final destination here. But you can, again, add over that 1310 passband port any legacy devices that are still running on this 1310 wavelength, anywhere from Sonnet, Ethernet, TDM. So again, just showing multiple wavelengths overlaid over the existing 1310 nanometer wavelength. Here's an application showing the use of that expansion port. And in this case, we have an 8-channel mux, as well as 2 4-channel multiplexers within a network. So all 8 channels are being multiplexed into this module here, and all 8 channels are being sent to the first location, where they're going to drop off 4 individual channels here. With the use of that expansion port, you can send the remaining 4 channels up to the next location here and drop off those 4 channels. So again, this expansion port is great for cascading from one location to another and dropping off wavelengths along the way. So now we'll go ahead and talk about why CWDM is great for the bottom line. So right off the bat, CWDM is going to save you time and money. So when it comes to installing new fiber lines, this can be very time consuming. So whether you're having to obtain permits from the city or do some trenching, or if you're doing aerial fiber and having to rent some pole space, or there could be obstacles in your way, like a railroad or a river or a mountain, and it's going to really take a lot of time to get that fiber in the ground. Or installing new fiber lines can be quite costly as well. We've heard estimates anywhere from $20,000 up to $50,000 or more per mile to install fiber cabling. Also, leasing dark fiber can be quite costly. So there are a lot of service providers out there that already have fiber laid in the ground that they'll gladly lease to you. However, they charge typically over $1,000 per mile, per month, per strand of fiber. So as you can imagine, that's going to really add up on your monthly payments for your fiber. But with CWDM multiplexers, again, we can increase the bandwidth over your existing fiber up to 16 times to prevent you from having to lay new fiber lines or install new fiber, rent new fiber, or lease new fiber from a service provider. Cliff, before we move on, any questions coming in on the Q&A right now?
Still waiting for questions right now. So if anybody has a question, just send it in.
All right, guys, come on. Get those questions coming in. Let's fire away. But now we'll go ahead and move on to CWDM multiplexers and show you the Omnitron line. So our iConverter is the platform that's going to support all of our CWDM multiplexers as well as the add-drop muxes. So Omnitron sells these in the dual fiber and single fiber varieties. With dual fiber, you can get a 4-channel or an 8-channel multiplexer or a 1 or 2-channel add-drop mux. On the single fiber, all those wavelengths are going to be cut in half. And so it's going to be either a 2, 4, or a 5-channel mux as well as a 1-channel add-drop mux. Omnitron also has multiplexers for multi-mode fiber in the 4 and 8-channel variety. And again, you can get these with those passband or expansion ports to add flexibility and scalability in your deployments. And then with the passive optical chassis, Omnitron has various chassis options available. So these are high-density CWDM chassis, can be front and rear loading, really pack in a ton of connections within that 2U high rack space. So taking a look at some of our CWDM multiplexers, as I mentioned, these are completely passive devices, and they can pass along any types of protocols, anywhere from Ethernet, T1, T3 TDMs, serial protocols. They have the dual fiber modules available in 4 and 8 channels, and we use what's called a band splitter module to combine 2 8-channel muxes in order to get up to 16 channels over a single fiber. And I'll show you an example of that here momentarily. With these 4 and 8-channel muxes too, we also have that optional expansion port, as I mentioned, as far as doubling the channel capacity, and that 1310 passband port, so that you can overlay up to 8 different CWDM channels over your existing or legacy 1310 networks. And then the other type of multiplexer I mentioned is the optical add-drop muxes. So these are perfect for whenever you need to add access along a CWDM link without impacting those remaining channels. So Omnitron makes these in the 1 and 2-channel add-drop mux options. On the 1 single channel, Omnitron has 18 different models that support each individual wavelength there. And then on the 2-channel add-drop muxes, we have a combination of various 2 channels such as 1270 and 1450 or 1470 and 1610, so you can drop off these 2 channels at one location. Here's taking a closer look at some of those OADM models. So this is the single channel dual fiber OADM. We got one right here, actually I'll show you. And so again, nice hard box, also shows you which wavelengths are being used on the sticker here. So in this case, we've chosen to drop off a 1590 wavelength at a customer location or at a point where you need to drop off that data. So just showing how this add drop mux works again. In this case, it can be a single direction or a dual direction. So all that data coming on channel 1570 here out to this location is being dropped off with our add drop multiplexer to Ethernet switch D in a single direction. But again, you can also drop off in multiple directions to switch E here with that same wavelength at the same location. On a 2-channel mux, very similar concept here, where you have the 2 channels that you want to drop off at that location selected. And then here's showing the application example using both a single and a 2-channel OADM or optical add drop mux using the upper 2 band of wavelengths here. So starting at the left side of the application here, using some Omnitron omniconverter Ethernet switches and CWDM SFPs installed. So we're going to send all these different variety of channels or data into a single multiplexer module, and then send each wavelength to its own individual location here, where it's being sent into one of our RuggedNet industrial PoE switches here as well. So again, the great thing about this, it can drop off data in a single direction at each location. And note that we're using the higher wavelengths here for some of these longer distances due to the lowest attenuation with these higher wavelengths being used. But then again, once all that data is being sent out to these switches, it can be used to connect to an IP camera, provide PoE power to it. We've seen these used quite frequently in transportation applications where they're hooking up traffic lights, and as well as Wi-Fi access points. So a variety of different applications can be used with this CWDM, whether it's security, transportation, or Wi-Fi connectivity. Now let's go ahead and take a look at some of the single fiber multiplexers. So again, these are, if you're using a single fiber within your network here, these are going to support half the number of channels of the dual fiber. So each channel is actually 2 different wavelengths being sent bidirectionally. So with our single fiber muxes, we have them available in 2, 4, or 5 channel muxes. You can also combine 4 channel muxes together with our band splitter to do 8 channels over single fiber. And then on the single fiber things for the optical add drop muxes, we have those 1 channel optical add drop muxes for these. And you can add and drop data in both directions. So as I mentioned too before, Omnitron also manufactures CWDM multiplexers for multi-mode fiber. So this is a nice unique advantage Omnitron has here. Not a lot of companies make CWDM multiplexers for multi-mode. So we make these in the 4 and 8 channel devices here for OM1 multi-mode fiber. These are perfect or ideal for buildings where it doesn't make economical sense to have to lay new single mode fiber within the building or replace that existing multi-mode fiber. So here's taking a look at an application using a multi-mode CWDM mux. So in this case here, running fiber from the ground floor all the way up to the 12th floor of a building using some gigabit Ethernet switches and multi-mode SFPs. And it's very, again, expensive to install new single mode fiber to do your multiplexing. And there may also be issues such as asbestos or firewalls or building regulations preventing you from pulling out this cable and adding new fiber cables. So what you can do is you use a 4-channel multi-mode mux here and send all of that data up this multi-mode cable all the way up to the top floor. And so these are typically going to be using the use of CWDM SFPs in these switches. And you're also going to require single mode to multi-mode conditioning cable when you're using the single mode SFPs. Again, this is a nice advantage Omnitron has, being able to do the multiplexing over multi-mode fiber as well. Now we'll go ahead and take a look at CWDM wavelength conversion and how you can connect your existing equipment or your existing infrastructure into a CWDM network. This can be done by the use of CWDM small form pluggable transceivers, or SFPs, as well as transponders, and these are fiber-to-fiber SFP-based modules, as well as media converters as well that support CWDM SFPs. So we'll take a look at each example here. So using a CWDM SFP, you can insert this into a gigabit or any type of Ethernet switch here that supports CWDM SFPs and send that CWDM wavelength directly into a multiplexer module. So Omnitron, as I mentioned, also does provide CWDM wavelength SFPs every 20 nanometers, and we color code the handle on our SFPs here so a network manager can easily identify the wavelength being used on their switch without having to remove the SFP and read the label of the device. Another way to convert from a standard wavelength into a CWDM wavelength is with the use of transponders. So a transponder is a fiber-to-fiber converter with SFP ports. And so these can also be used to convert from multi-mode to single mode just by installing a multi-mode SFP in port 1 and a single-mode SFP in port 2. Or you can use them to convert from a standard wavelength into a CWDM wavelength. So such as your 1310 or 1550 standard wavelength in port 1 and a CWDM SFP or XFP in port 2 of the device. So this will do your wavelength conversion, again, from a standard wavelength into that WDM wavelength. Another way you can do it is with media converters that support SFPs. So all Omnitron's media converters will support the CWDM SFPs and work in a wide variety of networking protocols and connector types. So applications showing a media converter, again, just coming off of an Ethernet switch here that does not have any SFP ports that support CWDM SFPs. So you can use a copper to fiber media converter, do that copper to fiber conversion, and just install a CWDM SFP in the media converter, send all that data into the multiplexer. And you can do this with different protocols such as T3 as well. So coax into our T3 converter, CWDM SFP sending the 1570 nanometer wavelength into the multiplexer. So just showing you how media converters, again, can convert from a standard wavelength into that CWDM wavelength. Here's another way to look at it with our 19 module chassis. So you can add media converters into the chassis, so your T3, your Ethernet, and again, converting those into the CWDM wavelengths, which will be fed into the MUX, or the multiplexer cards. Then you can add transponders to go from, again, a standard 1310 wavelength into another CWDM wavelength as well. You can also add some network management modules or network interface to devices for management capabilities within a chassis. So we're talking about multiplexing data. Again, each wavelength must be converted into a CWDM wavelength before a multiplexer module will accept it. So showing you a few different ways to do that here on a gigabit Ethernet switch. Again, if it supports the CWDM SFPs, you can just install that right into the GigE switch there and provide a 1510 nanometer into the multiplexer. If you have some legacy equipments or routers, again, that don't support CWDM SFPs, that's when you can use that transponder. So install a 1310 standard wavelength SFP into the transponder, as well as a 1530 CWDM wavelength into that transponder to provide that 1530 to the multiplexer. And then again, just showing it with a higher rate gigabit 10 gig switch here, and the use of our 10 gig media converter with the CWDM SFP, or a T3 MUX with a T3 media converter in the CWDM SFP. Again, this is just showing you multiple data rates, multiple different protocols, all being multiplexed or combined into a CWDM multiplexer module. Now we'll take a look at some of the chassis options for CWDM. Omnitron, we have our 19-slot chassis, also a 5-slot chassis, a 2-slot chassis, or a single-slot chassis. So that same multiplexer module card can be redeployed in various areas of your network as your needs change. So the 19-module and the 5-module chassis also feature redundant hot swappable power supplies. You can power these by AC, DC, if you're using them for management. However, if you're not using management, they don't need to be powered, as these are completely passive devices. Again, so as I mentioned, the same standard card here can be just snapped into one of our chassis, clicked in here, and then just easily tightened up with the thumb screw. We also have a 19-module compact chassis and the cable management kit. So what we've done here is we've removed the power supplies from our iConverter 19-slot chassis, and so you can really pack in a ton of connections in this 2U high space. So these bolt back-to-back, so you can do front and rear loading and really provide up to 684 CWDM connectors in this 2U high rack space. Then as you can imagine, with all that fiber coming out of this chassis, we also have the cable management kit. It's part number 8095-1. This just bolts onto the front of our chassis here. It can also swivel up and down so that you can remove modules and install fiber. Another offset of the Omnitron's optical family is called the Omni Lights. So these are for customers that are using the LGX form factor as far as their chassis or shelf goes. So we have different CWDM, DWDM multiplexer modules that will fit into this LGX chassis, or we have a bracket that you can take and just put this over our standard iConverter multiplexer card here and insert this into an LGX form factor style chassis. Now we'll go ahead and take a look at some more application examples here showing you how CWDM can really help you increase your fiber bandwidth. So data center interconnectivity. In this case, we have two data centers being connected, and these could be across the street or across town from each other. And they're going to be connected with fiber using CWDM. So what they need to do is connect their different storage devices through this fiber channel switch. And so we're going to insert an iConverter 19-slot chassis with a 4-channel MUX card here in one of the slots. And then with the use of those transponders and a standard wavelength SFP and a CWDM SFP installed to do that conversion into a CWDM wavelength. And you can do that with multiple channels, each getting their own color wavelength or their own nanometer of wavelength. So now what we've done is combine 4 different channels into this MUX card, send all 4 channels over to data center 2, where we have a mirror solution over here. Same exact part numbers, it's going to demultiplex those wavelengths, send it into the transponder where it's going to convert it from CWDM back into the standard 1310 or 850 nanometer wavelength in order to provide connectivity to these fiber channel switches and storage devices. So again, we've transported 4 separate channels up to 100 kilometers here over a single fiber cable. So this is really going to help you prevent having to lease more fiber from a service provider out there or lay more fiber cables here if you can just send more data, more channels over that existing single fiber. Again, this can all be managed by installing a network management module here in slot 1 of our chassis. You can also multiplex 10 gig over CWDM. So this is used with our XG Plus transponders and our SFP Plus or XFP transceivers. So a very similar application. This time we're going to use the 5-module chassis, and we're going to install that same 4-channel MUX card as well as some 10 gig transponders, our XG Pluses. These have those high-power XFP transceivers for the long-haul data transport. So again, just converting it from a standard wavelength into a CWDM wavelength. We're doing that 4 separate times here and sending all 4 10 gig channels or 40 gigs over this common fiber line here over to data center 2. And so in this case, what we've done again is maximize the existing fiber, sent more data, more channels over their existing fiber, preventing them from having to lay new fiber or lease new fiber from a service provider. Speaking of service providers, let's take a look at how service providers use CWDM in some of their applications. So when they're delivering business services or doing mobile backhaul from a cell tower, CWDM can really come into play, help save them a lot of money on fiber as well. So in the application looking here at our 19-slot chassis, using transponders to convert some Gig E switches into CWDM, as well as some T1s and some more Gig E from a wireless IP network. Sending all that data through our CWDM 4-channel MUX card out to a 4-channel multiplexer here where we'll demultiplex, give each wavelength to a business subscriber or out to that mobile cell tower area. So again, just having multiple different protocols all being sent to one location over this common fiber line really helps save money and time on laying that fiber. CWDM can also be used for access networks and also in enterprise type applications. So again, when you're leasing fiber or providing fiber to subscribers at a building, it's much easier to send all that data instead of having to lease or build more fiber lines to multiple tenants if you can just do it all over one fiber strand. Here's taking a closer look at that CWDM enterprise application where you have our 19-slot chassis with a few different CWDM multiplexer groupings all installed on this one chassis here. So again, all the 16 different channels coming from the switch here at the core network. And from there, they're going to be combined with our 2 of our 8-channel multiplexers into what we call the band splitter. It's part number 8865-0. So you have the upper band and the lower band both being combined into these channel ports, and then all that data being sent over the common, out of the common port over this common fiber access link out to the corporate buildings. Now, once it reaches that corporate building, again, that fiber here is going to be handed off from a service provider to their subscriber, to their customer. And at this point, this is where they're going to convert it back from a CWDM with our multiplexers into those transponders. And in this case, there's multi-mode fiber already laid in the building. So they use multi-mode SFPs in these transponders to send all that data up to the individual demarcation devices or network interface devices within the network. Again, nice way to do some delivery of Ethernet services to business customers or within your own enterprise network if you need to distribute more fiber to more areas within the network using CWDM. CWDM can also be used for some DAS applications, again, where building operators or service providers will install DAS antennas within a building here to provide better cell coverage for the tenants. And so in this case here, we're delivering individual wavelengths to all these different radio access units or antenna on each floor of the building. And then we're also using that expansion port to drop off 4 more wavelengths at the upper floors here as well. CWDM can be used for outdoor DAS applications. We've actually run into situations where you have multiple service providers all sharing real estate at these radio access units here, these antennas or cell towers. So the application here is showing our 5-module chassis, and it has the 4-port, 4-channel MUX cards installed, and also 4 of the XFF transponders again. So each mobile operator has 2 separate wavelengths within their network here. So again, the multiplexers are being used as a data transfer point to send multiple channels of data out to each of these radio antennas here, using the same mirror solution out of at the poles in order to do the demultiplexing and converting back from CWDM wavelengths into these standard wavelengths. CWDM can also be used for Ethernet access ring applications here. So again, all this data coming from the core network being sent into our 2-channel or our 2-slot chassis here with 2 of our 8-channel MUX cards. Now all that 8 channels are being sent bidirectionally through this fiber and dropping off a single wavelength in 2 directions. So you're dropping off data to this location as well as receiving data and putting it back onto this fiber ring. And we're dropping off with the optical add drop muxes at each location and adding more fiber as well or more data to this ring. Now, if there is any cuts or breaks in this fiber line here, that's where the failover protection comes into play as far as our ring architecture. So all the data will be sent the opposite way here of the ring. So a great way to provide some redundancy within your CWDM network here. And again, drop off multiple wavelengths at each location. Here's showing the 2-channel add drop muxes in a very similar ring application. We're using a 2-channel add drop mux at each location to drop off data in both directions to 2 separate switches here or 2 separate customers within your network. So quick summary and key takeaways from today's webinar. CWDM, coarse wave division multiplexing, combines up to 16 channels of data on that single fiber cable. It's going to allow you to quickly increase fiber bandwidth capacity over your existing fiber lines or new fiber lines as well. You can also transport different protocols or data rates simultaneously, and you can overlay these CWDM wavelengths with the standard 1310 or 1550 nanometer wavelengths in your network. And then you can use those add drop muxes to add or drop off various channels at different locations. And really with CWDM, this is saving a lot of money from having to lease or install new fiber lines. And also it's going to save a lot of time from having to install those new fiber lines. So you can really become a superhero within your network by adding CWDM multiplexers and saving your company a ton of money here on your fiber lease payments or fiber installation payments. And then with the use of those transponders, again, converting from standard wavelengths into CWDM wavelengths. And then Omnitron also has the CWDM SFPs that go into our media converters, our transponders, our switches, each with their own CWDM wavelengths. So here's a nice list of questions for you as well when you're trying to determine your CWDM needs in your network. The first one up is how many channels or how many wavelengths are needed? And then the type of fiber you're using. Is it multi-mode, single mode, dual, or single fiber? Also, what's the distance between each location in your network? And do you need that 1310 passband or expansion port as well? Also, chassis options. How many CWDM modules are going to be installed in each location? As well as, are there going to be any adds or drops as far as the optical add drop muxes along the way? And then are transponders needed from converting it from a standard wavelength to a CWDM wavelength? And if so, what speed? Is it the gigabit or all the way up to 10 gig speeds? And then are the CWDM SFPs needed as well? And if so, in which wavelengths? So nice list of questions here to really help diagnose your CWDM needs for your network. And lastly, why would you choose Omnitron CWDM multiplexers? Well, for one, they're made in USA. You're going to get a quality product. Two, the compact size and flexible design. So Omnitron's multiplexers are super small, very compact, and they're flexible. They can snap into all of our different chassis options here, and you're not stuck with a fixed chassis of CWDM multiplexers. Also, another reason to choose Omnitron CWDM multiplexers is because they work with both single mode or we have multi-mode models available. And then these can come in commercial temp or in wide temp for outdoor deployments. -40 to 60 degrees Celsius rating is very nice. Omnitron also offers that free 24/7 tech support as both pre-sales and post-sales to help you design your CWDM network. No service contracts with Omnitron equipment, and there's also no minimum order quantities or any drop ship fees. So again, we really try to make it easy to work with us. So if you'd like to learn more about CWDM, you can visit Omnitron's Resource Center on our website, where we have our iConverter CWDM Design Guide white paper, as well as more white papers on deploying SIP-free front haul with CWDM, and a few service provider case studies, as well as more video tutorials to really show you how CWDM works and also how to deploy these in various other applications. And as I mentioned, if you need any help at all designing your CWDM network, please give your Omnitron sales rep a call, send them an email, and again, we can help you out with the free network design assistance and really putting the CWDM network together with you. Or you can email us at info@omnitron-systems.com as well. Many ways to get in touch with us. With that being said, just want to thank everyone again for all your time today and joining us for this webinar. Again, if you'd like to reach out to us, you can reach us at info@omnitron-systems.com. Here's a look at our phone number as well and our website too.